Shows you're concentrating and don't look so terrified. The title of our exhibit is Mind Reading Machines, which sounds a bit like science fiction, but it's not actually. Mind reading is a term that psychologists use for something that people do every day. When we talk to each other, we make expressions in our face, we watch other people, and it's an important part of the communication, just as important as the words. And people that don't actually do this are at a disadvantage. It's people with autism spectrum disorders. And in that sense, computers ignore all these. They're autistic. And we're trying to do something about it.
Mouth point, eyebrow point, nose, and then it's associating the movements of these features with different head gestures.
People interact with machines and computers more and more every day, and sort of our level of expectation of what these computers could do and how they respond to us is really increasing every day. And so now is the time to build these sophisticated machines that can respond adaptively based on your emotional state. Otherwise, it's not a very rewarding experience.
So we have a computer system that uses a camera to watch your face and tracks points on the face, the mouth, the edges of the eyes, the eyebrows. And from those, we can work out the expression on your face and gestures you're making with your head, nodding or shaking. And then we take a library of 2,500 video clips of actors acting emotions and do the same analysis of those. And then with a bit of probability theory, we can interpret the gestures that a person is making and work out what the probable emotion is. Well, when people are expressing emotions, they don't just do it through their faces. They wave their hands around in gestures. Their whole body posture says something about what they're thinking. And we're trying to observe that as well. Now, it turns out that tracking the face is hard, but we can do it without adding anything to the face. Tracking a body is a bit more complicated.
Body language is another channel by which human beings work out the mental state of somebody they're dealing with. And we want to know whether it's possible for the computer to pick up body language in the same way that we were able to do it for face. Now, the current state of the art is that you cannot reliably track body language just from a video of a person. So we've invested in a motion tracking system which allows us to do this by attaching little markers to a human being and tracking those. Our hope is that in 5 years' time, doing the motion tracking from video will be feasible. We'll be able to use that motion tracking and feed it into the results we've got from tracking these little markers on people.
This matters generally because at the moment computers ignore their users, and people who do that are regarded as rude. Using a keyboard and mouse is a way of interacting with computers that's been around now for 30 years, and we need to move on and try and bring the level of communication between people and computers up to the same level as between people and people. And that's not just people using workstations. Increasingly nowadays, computers are embedded in the environment around us, and they're driven by sensors. And this is just another channel of sense that the computers can have to help understand what they need to be doing at any time.
The reason we can do this now, and why this was not possible 10 years ago, is that it uses an immense amount of computer power to get all of those statistical models processed through in real time so that we can do this from live video. 10 years ago, computers just could not do this. Today, a desktop computer can do this, and in 5 years' time, you might be able to see a simple version of this on something like a mobile phone.
The team mainly consists of computer scientists because that's where we're bringing new insights to bear, but we need to understand the underlying disciplines in psychology and in computer vision. And we're very lucky in Cambridge. We have the psychology department which has experts in emotion that we can go and chat to. We have to do mathematics because a lot of this is based on probability theory, and we need to understand that. But really it's systems engineering. We're building large systems, and we need people who can understand how to make large systems out of software with a little bit of hardware on the side. And then there are all sorts of routine computing jobs. You can imagine an online shopping system where a webcam monitored your face, and if you saw something you liked, it would show you more of the same, and if it showed you something you didn't like, it would show you something different. Or for an online teaching system, it could see if you were understanding, and then the lesson could go a bit faster, or if you were confused, and it could cover some of the material again.
So there are a number of different applications of our research. The first is to get computers to be emotionally aware and respond in a socially intelligent way to its users, so that human-computer interaction becomes more intelligent and more satisfying. And so we're putting this onto robotic platforms, desktop machines. So that's one sort of application. The other is trying to build wearable technologies to help people with autism learn about emotions and facial expressions. Because in a sense, technology is oblivious of users' mental states in the same way people with autism are sort of mind blind or blind to these nonverbal cues.